Alright, this is chapter 1, section 3 and 4, midpoint, distance formulas, and angles. Alright, so this section deals with finding the middle coordinates called the midpoint. Definition that the book gives for the midpoint is a segment is a point that divides the segment into two congruent segments. So we have some line segment A and B. We have some other point M. Right? And M is the midpoint. M is exactly in the middle. So what does that mean? Since M is in the middle, it cuts this particular segment AB completely in half. So that means that AB is congruent, or AM rather, is congruent to BM. So AB is cut in half. So point M is the midpoint. Or yeah. Point M is the midpoint. And since it's the midpoint, I know something about this. What do I know? I know that I now have two segments. I have segment AM and I have segment MB. And since I know that M is the midpoint, I know that these two guys are congruent to each other. So AB is cut completely in half at the midpoint, and I have two other segments that are congruent to each other, where these little markings means that they're congruent. So AM would be congruent to MB. Now, further suppose we have some particular point, line, ray, or line segment. If I have something going through the midpoint, then I have a segment bisector. A segment bisector. Bisector means to cut in half, to bisect. Bi meaning two, to cut into two pieces, two equal pieces. So I have a segment bisector. So in this case I have some line DC. I would say that line DC is the segment bisector of AB. It can be a line, it could be a line segment, it can be a point, it could be a ray, and it could be a plane that goes through the midpoint. And put MP for midpoint. That goes through the midpoint. Line, segment, point, ray, or plane that goes through the midpoint is called the segment bisector. Alright, so with that we can do some certain things. So let's go through these two examples. So example 1. We're given, they want us to identify the segment bisector of PQ, then find PQ. So I'm going to just enlarge this over here to the left. I have for number 1, segment PQ being bisected by MN. So, and that's a ray. So ray MN is the segment bisector. I'll just put seg bisector to save time. So I found the segment bisector. Now they want me to find the distance of the whole entire line segment PQ. I know that PM, segment PM, is equal to segment MQ. So since I know that PM is equal to PQ, and I know that PM is equal to 1 and 7/8, which is equal to 15/8. So since I know that PM is equal to 15/8, I can also say that MQ is also equal to 15/8. Since I know that since I know it's the midpoint, and I know that they're equal to each other, I also know that PM plus MQ is going to equal PQ. So I can find PQ by adding PM and MQ. So this is 15/8 plus 15/8, which equals PQ, which equals 30/8, which gives me 15/4. So PQ would equal 15/4. And I don't turn things into improper, so I would leave it at that. For number 2, the segment bisector is line L. So line L is the segment bisector. Again, I know that PM is equal to MQ, and I know that PM plus MQ equals PQ. So I know that PM is equal to 5x minus 7, and I know that MQ is equal to 11 minus 2x. Then I can set these two guys equal to each other and say 5x minus 7 is equal to 11 minus 2x. And then solve. I can add 7 to both sides, and I can add 2x to both sides. And that gives me 7x. What an ugly number that I'm going to have. 7x is equal to 18. Divide by 7. And I get that x is equal to, I get x is equal to 18/7. But they don't want me to find x, right? They want me to find PQ. So x is equal to 18/7. Once I get that x is equal to 18/7, then I have to find what, I use either one, it doesn't matter. Ooh, this is going to be an ugly number. I'll plug in 18, I use the PQ, so 5 times 18 sevenths minus 7 gives me 90/7 minus 49/7 and then I get 41 over 7 equals PQ. Sorry, PM. Okay. So PM is 41 over 7, so I know PQ is double that. So 41 over 7 plus 41 over 7 is 82 over 7. And that would be my PQ. And I will leave it at that. It would have been so much easier if it was 42 over 7. Okay. Midpoint formula. Hopefully this is all reviewed. So I have two coordinates, x1, y1, and x2, y2. And the midpoint formula says that I can find the midpoint of this particular segment by adding the two x coordinates and dividing it by 2, and adding the two y coordinates and dividing it by 2, and that's going to give me the midpoint of a particular segment. So midpoint formula. It doesn't matter which number I call my x1s and my x2s or my y1s or my y2s, they should get you to the same place. So let's do an example. Or 3 or 4 or 5. So we have, there's two ways to use the midpoint formula. You can use the midpoint formula to find the midpoint, and you can use the midpoint formula to find the endpoint. So we would have an endpoint, and a midpoint, right? So this is the endpoint, this is the midpoint, this is the endpoint. We can use the midpoint formula to find the midpoint, or we can use the midpoint formula to find either one of the endpoints, depending on the information that they give you. So in number 3, they give me 2 endpoints. So they want me to find the midpoint, the coordinates of the midpoint. So we have point A, which is 1 and 2. We have point B, which is 7 and 8. And the midpoint formula is, just like I wrote earlier, x1 plus x2 over 2, and y1 plus y2 over 2. It doesn't matter which one I call which. So in this case, I'll just call these my x1s and my y1s, and this my x2 and my y2. But it really doesn't matter. So to find the midpoint of AB, or M, we'll just add. So midpoint, I'm going to call it M, equals 1 plus 7 over 2, and 2 plus 8 over 2. That gives me 8 over 2, 10 over 2, which is 4 and 5. So the midpoint coordinate of 1, 2, and 7, 8 is 4 and 5. Yay. So that's the case where they give you 2 endpoints and they want you to find the midpoint. When they give you a midpoint and an endpoint, it's a little bit more complicated, but the same thing applies. So in this case, they give me a segment VW. They give me that W is 4 and 4, and they give me that V is, we don't know what V is. That's what we're looking for. So we'll call V X and Y because that's what we're looking for. And they give me the midpoint, and the midpoint is -1 and -2. Uh, Again, the midpoint formula is midpoint is equal to x1 and x2 and y1 plus y2 over 2. So here's where the difference arises. So since we're given a midpoint and an endpoint, we have to find this individual coordinate separately. So we can start off by trying to find the x coordinate first. So we know that the midpoint coordinate of x is -1. So this is going to be my midpoint, and that's going to equal 4 plus x, if you want to call it x2, you can, it doesn't matter, over 2, right? And then we're solving for x. We multiply both sides by 2. That gives me -2 equals 4 plus x. Subtract both sides by 4, and then -6 equals x. So we found the x coordinate. Then the next thing we got to do is find the y coordinate. And that's going to be -2 equals 4 plus the y over 2. Again, multiply both sides by 2, and I get -4 equals 4 plus y. Then I subtract 4 on both sides, and I get that -8 equals y. So I got my x and my y. So v, endpoint v, is equal to -6, -8. So when they give you an endpoint and a midpoint, you're going to have to find the x and the y separately with the midpoint formula, coordinate specific, and go that route. Distance formula. So distance formula is basically a derivation of the Pythagorean theorem. So if we remember the Pythagorean theorem, I need a 90-degree triangle. Doesn't work with us. It's a 90-degree. I have an A side and a B side and a C side, right? So I know that from the Pythagorean theorem, Pythagorean theorem, I got C squared equals A squared plus B squared. If I want to find C, which is the hypotenuse, I'm going to square root everything, right? So C squared squared root equals A squared plus B squared square root. So then I know that C equals A squared plus B squared square root. So let's say I had some coordinates, right? And let's say that on my A side here, this guy was x1, y1. And let's say this guy over here was x2, y2. And let's say this guy here was x2, y1. Well, I can get the distance to get that guy, the distance to get that guy using the distance formula for a straight line. So that would be the absolute value, right? So x1 minus x2 square root. Remember that guy? And then for this part here, I can get it by using, actually, I did it wrong. x2 minus x1. Right? That's going to give me the a distance. And over here, I can use y2 minus y1. And that's going to give me my b distance. So I'm going to put that for A, I'm going to put that for B. So then I can say that C is equal to x2 minus x1 squared plus y2 minus y1 squared. And then I square root the whole thing. And that is the distance formula. So the distance formula is a derivation of the Pythagorean theorem. And what I just wrote is right here on the next page. When I do the distance, I substitute that for B and C, A and B, and then I use the Pythagorean theorem to find square root. So, when you do this problem, what I like here about the example 5, it asks if it matters if which ordered pair is your x1s, y1s, x2, y2s. It does not. So we'll do that with number 6. We'll do it both ways. So for the first part, we have our distance formula, which is distance equals x2 minus x1 squared plus y2 minus y1 squared, and the whole thing is square rooted. They give me that A is equal to -3 and 2. They give me that B is equal to 1 and -4. And they want me to find the AB. Alright, so I'm just going to plug it in. So AB, the distance of AB, is equal to, I'm going to call this my x1 and my y1, and I'm going to call this my x2 and my y2. So that's going to be 1 minus -3 squared plus -4 minus -4 minus 2 squared. That's going to give me 1 plus 3, which is 4 squared. -4 minus 2 is -6 squared, which is going to give me 16 plus 36, which gives me 52. And I square root that, and that gives me approximately 7.21. So that's my distance of AB. So AB equals 7.21. I rounded to the nearest hundredth. It's like 7.21110, blah, blah, blah. So I can do it that way, with this being my x1, y1, and x2, y2s, but I can actually switch it and I should get the same answer. So let's see if that happens. So instead of it being 1 minus negative 3, I'm going to have a negative 3 minus 1. Instead of negative 4 minus 2, I'm going to have negative 2 minus 4. So I switch my x1s and y1s and my x2s and y2s. That gives me negative 4 squared plus negative 6 squared which gives me 16 plus 36, which also gives me 52, which also gives me 7.21. So it works. Make sure that when you do this, you don't subtract like x1 minus y1. They have to both be x coordinates and they have to both be y coordinates when using the distance formula. So the answer for a 6 would be B, both ways around. They rounded to the nearest tenth. Okay, that's 1-3. Then we have 1-4, classifying angles and classifying angle measurements. So we have things here. We have this angle. What is an angle? Angle consists of two rays. I have a ray here, I have a ray here. And these two rays share a common endpoint, so the same endpoint. So that's my endpoint. That's my endpoint. Both of these rays share that endpoint. So if I call this A, and if I call this C, if I call this B, I have ray AC, and I have ray AB. Two rays that share a common endpoint. AC, this would be considered the sides of the angle. That's a side. That's a side. The common endpoint that they share, we don't call it endpoint, we call it a vertex. So the vertex of an angle is the common endpoint that they share, and it consists of two sides. The sides is the ray itself of the angle. When we label these things, we label it like this. We would call it angle CAB, or we can call it angle BAC. A has to be in the middle. A has to be in the middle because A is the vertex. So since A is the vertex, A is in the middle. Always. So when you label this and you don't have the vertex or the common endpoint that they share in the middle, you done did something wrong. You can also classify this by calling this by its vertex angle. So it's CAB or angle BAC, or you can call it angle A by the vertex. So those are three ways that you can classify it. Measuring angles using the protractor. This is the protractor postulate. I'm not going to harp too much on the protractor postulate thing. I'm not going to stay there too long. But if you're measuring the angle from the right side, you use the inside measurement. If you're measuring the angle and the bottom rays on the left side, you do the outside measurement. That's about it. So if I was to measure angle AOB, it would be from the right side, it would be 140 degrees if so this was a 140-degree angle. Okay. What types of angles? Classifying angles. So we have an acute angle. An acute angle is an angle that's in between 0 and 90 degrees. Between 0 degrees and 90 degrees. By the way, we measure angles by using the degree symbol. So when I ask you what the angle is, it's going to be in degrees. So the book has it like this, and they call it A. The technical geometrical term, when I ask what the A equals, we would say the measurement of angle A. So measurement of angle A would be some angle between 0 and 90 degrees. Obtuse, or right, let's do right first. Right angle is an angle that's exactly 90 degrees. And we know that something is 90 degrees because we have the little box symbol. So here's an example of a right angle. It has the little box here, and that tells me that it's 90 degrees. Obtuse is an angle between 90 and 180. And actually, I'll draw these types of angles in a second. Then we have a straight line, or a straight angle. A straight angle is a straight line. And that's a line that is exactly 180 degrees. So acute between 0 and 90 degrees, right angle exactly 90, obtuse between 90 and 180, and straight angle or straight line exactly 180. So an acute would look like that. Right would look like that. Obtuse would look like that. Get my arrows so that they're raised. And then straight would look like that. Okay. So this example that they give us, they want us to name all the angles in the diagram, which is the right angle. So we have this angle. This is number 1. I see 3 angles in here. 1, 2, 3. So we have angle PQS, right? And that's a right angle. We have angle PQR, and that's a acute. And we have angle RQS, and that is also an acute angle. I know that PQS is 90 degrees because of the little box, and since I know that PQS is exactly 90 degrees. I know that these two other guys have to be less than 90 degrees because when I add them up, they give me 90. So PQR has to be acute, and it looks acute, and RQS is acute. The next question says to draw a pair of opposite rays, what type of angles do opposite rays form? We know that opposite rays have to be on the same line. We can say P. So opposite rays form a straight line. Angle addition postulate. So the angle addition postulate says that if P is the interior of RS, then the measure of RST is equal to the sum of the measures of RSP and PST. Alright, so what does that mean? When we have an angle, everything on the inside is called the interior. Everything on the outside is called the exterior. Right? Makes sense. Outside, exterior, and inside, interior. We can have another ray such that we would call this interior ray or interior angle, where we have another subset of angles in the interior of the outside angle. So what they're saying is that if I have some main angle, the exterior angle, or the bigger angle, I can say that it's the sum of adding these two guys in the middle. So we call this R, we call this S, we call this P, we call this T. So the biggest angle, the main angle, is angle RST. And what the angle addition postulate says is that the big angle is comprised of the sum of the smaller interior angles, the angles inside this particular angle. So it's the sum of RSP and angle PST. That is all it says. By the way, notice it has these little curvature markings. That just means that these two angles are congruent to each other. So it's an angle bisector, which we'll talk about later in life. Alright, so knowing that it's that they sum up to the main angle, we can use the angle addition postulate to find the angles. So looking at this guy, we're told that it's a straight angle for number 3. Right? We're told it's a straight angle, so angle, we'll say angle KLM is a straight angle. So if it's a straight angle, I know that it equals 180 degrees. I also know, because of the angle addition postulate, that angle KLM is equal to angle KLN plus angle MLN. I also know that KLN is equal to 10x minus 5, and I know that angle MLN is equal to 4x plus 3. So what can I do? I can substitute. I'm going to substitute 180 for KLM. I'm going to substitute 10x minus 5 for KLM, and I'm going to substitute 4x plus 3 for MLN. And combine like terms. I get 14x minus 2, add 2 to both sides, and then divide by 14. and I get that x equals 13. But they want me to find the angles. So now that I know that x equals 13, I could find angle KLMN, which is equal to 10 times 13 minus 5, which equals 130 minus 5, which equals 125. And I can find angle MLN. That's 4 times 13 plus 3. 4 times 13 is 52. So that's 55. And these guys are in degrees. Oh, yeah. 25, 55 degrees. And when I add it up, 155 plus 125, that gives me 180 degrees, which is a straight angle, and that's the angle of the main angle, so it works. Hallelujah. Okay. For number 4, they give me angle EFG equals 90 degrees. I know that angle EFG is equal to angle EFH plus angle EGFH. I'm given that EFH is equal to 2x plus 2. And I'm given an angle GFH is equal to x plus 1 degrees. Alright, they want me to find the angles. So I can substitute 90 for angle EFH, and I can say that is equal to 2x plus 2, which is substituting for angle EFH. So EFG is 90, EFH is 2x plus 2, and then GFH is x plus 1. Combine like terms, and I get 90 is equal to 3x plus 3. Subtract 3. I get, not 90, I get 87. It's equal to 3x divided by 3. And I get that x is equal to 29. Alright, so x is equal to 29. Then I'm going to substitute that back in. So, angle EFH equals 2 times 29 plus 2, which is 58 plus 2, which is 60. And then GFH equals 29 plus 1, which is 30. And then 30 plus 60 equals 90, so that works. Congruent angles. Two angles are congruent when they have basically the same measurement. Notice that I know that they're congruent because here's angle A. And now, no, this isn't to scale, y'all. And angle B. I know they're the same because of this marking here, this little curvature. Since there's one curvature here, I would say that A is congruent to B. If they both had two curvatures, then I can still say that A is equal to B. As long as the ticks are the same, I call them ticks, or curves are the same and the same number, then they're equal, or congruent in this case. When we talk about congruency, the book differentiates between measurement of the angle and the angle. If I'm talking about the measurement of the angle or the degrees of the angle, that's the numerical value. Then we use the equal sign. If I'm talking about the angle overall, size and shape, in addition to numerical value, then I'm using congruency. Alright, we have this pentagon over here. They want us to identify all pairs of congruent angles. So I have that pentagon. This has two markings over here. This has two markings over here. So I can say that angle P is congruent to angle R. This has one marking. This has one marking. So I can say that angle T is congruent to angle S. Angle Q has no markings at all, so that tells me it's not congruent to either these two angles or it's not congruent to the other two angles. So that is all she wrote. It says in the diagram, they give me the measures of the angles and they want me to find the other angles. So PQR QRS. Alright, so since I know that angle P is congruent to angle R, so this would be QRS. And since I know that angle R, the measurement of angle R, is equal to 84 degrees, since I know that R and P are congruent, then the measurement of angle P is also equal to 84 degrees. They give me angle TSR, which is angle S, is 121 degrees. So if the measurement of angle S is 121 degrees, then I know the measurement of angle T is also 121 degrees. Because they're congruent to each other based off of the diagram. We're not constructing any angles. We're not constructing any angle bisectors, so you don't have to worry about that. However, if we were like in a regular class, there might have been a possibility. Angle bisector. So we talked about a concept of the segment bisector earlier in the previous section. So if a segment bisector cuts an angle in half, then an angle bisector cuts the angle in half. So angle bisector is a ray that divides an angle in half. Just cuts it in half. So if I have some angle and I have some ray that does that, and I'm able to write these two markings, then I know that this ray, and let's call it ray AB, ray AB would be the angle bisector because it cuts this bigger angle in half. That's all it is. So knowing angle bisector, since they're cutting half, I can add the two smaller angles together to get the other one if they're of the same size using the angle addition postulate. Alright, and number 7 says MNP is a straight angle, NQ bisects MNP, draw MNP. Alright, so we're not doing that. I just actually did it. But if you wanted to, so MNP, let's call it a 90-degree angle. MNP and then we have some ray NQ. And it cuts it in half. And I know that it cuts it in half because it gives me the markings. And that's it. Since I know that it cuts it in half, and I know it's a 90-degree angle, I would know that the smaller angles, angle M and Q, would be congruent. Actually, do this. The measure of M and Q would be equal to the measure of P and Q, which would be 45 degrees. Alright, and that's this section. I hope you have a great rest of your day.